We're on for an hour from now. So any questions on the anything on the review sheet, on the latest one, or on other review sheets, on other exams, anything? Section 1.5, questions 2 and 3. So let's look at that. Section 1.5, which is a washer method about other horizontal axes, number 2 and 3. Okay, so let's look at that. So section 1.5, number 2. So what do we have? We got y equals e to the negative x. We got y equals 1. We got x equals 2. And we're going to rotate the region about the axes y equals 2. So a crucial step for this is to graph and sketch the region correctly. So we should know that y equals e to the negative x is an exponential decaying function. So this would look like the equation, right? Just give me 1 second. Sorry about that. Okay, so this is y equals e to the negative x. Y equals e to the negative x. And then what do I have? I got x equals 2. So x equals 2 somewhere here. So then this would be x equals 2. Just give me one. Sorry, guys. Okay, sorry about that. So x equals 2. And then what else do we have? Y equals 1, right? So y equals 1 is this line here. I should have made it a little bigger. So then what's the region that I'm considering? I'm considering this region here. And where am I rotating this around? I'm rotating this around this axis. This is my axis of revolution, y equals 2, right? Axis of revolution. Now I'm going to rotate this. I'm going to revolve this region around this axis. So then what am I going to form? I'm going to form, maybe I should draw it with this. I'm going to form this kind of shape here. Something like this, aren't I? Now, the question becomes, how do I find the volume? What am I going to use? The disk or method or the cylindrical method? Obviously, it's going to be the washer method. So then what would be the volume? The volume is pi evaluated from 0 to 2. Now, what's going to be the outer function? I mean, what's going to be the outer radius? That's the hard part, right? What's going to be the outer radius squared minus the inner radius squared? So what's going to be the outer radius?
Would it be e to the negative x? Or 2 minus e to the negative x?
Yeah, it will be 2 minus e to the negative x. So let me just write that down. So the outer would be 2 minus e to the negative x. And what would be the inner? The inner would be what? What's going to be the inner, what inner radius? Remember, the inner radius is with respect to the axis of revolution. So the inner radius would be what? Will be, yeah, the inner radius is just 1, guys. It's constant throughout. The inner radius here is constant throughout because I have a constant function, right? I have this constant function y equals 1. So then the radius is 1. So then I'm going to set up my integral from 0 to 2. Then I got 2 minus e to the negative x. I square this minus 1 dx. So now what is 2 minus e to the negative x? When I square this, what does this become? So remember, we should do this slowly just to make sure we do everything correctly. And then when we expand, we get 4 minus 4e to the negative x plus e to the negative 2x. So that's going to be pi evaluated from 0 to pi of 4 minus 4 e to the negative x plus e to the negative 2x minus 1 dx. So this will equal pi multiplied from 0 to pi of 3 minus 4 e to the negative x e to the negative 2x dx. This looks very similar to one of the problems that we did in class where I had completely overlooked evaluating it at 0. Oh, I forgot the question. Samantha says, what if the axis of revolution was below the function instead of above? Would you add instead? So that's an excellent question. So what if the axis was not here, but here instead, correct? Then you just have to understand the geometry of the scenario. So what's the geometry? The geometry is the outer radius. What would be the distance between? So for example, I guess we can do another one of these, okay, Samantha? After we finish this one. So you see the difference. That's an excellent question. So this would be what? Y equals pi. And then we take the antiderivative. So it becomes 3x. Then this becomes what? Plus 4e to the negative x, right? Because we take the antiderivative. This negative here pops up. And then this becomes, sorry, this would be a plus here. This becomes negative e to the negative 2x over 2. Okay, does everybody agree with the antiderivative? Why is it from 0 to pi instead of 0 to 2? I have no idea why. I think I saw pi and I just kept on writing pi. You see, these are things that I also ask myself when I see some of the work from different students. I'm like, wait, how did you? This just happens, right? I'm looking at pi every time, so I just want to make sure that pi is there. That's why I put the pi. But you're right, it shouldn't be pi. It should be 2. Thank you. So this becomes 0 to 2, and I'm evaluating it from 0 to 2. Okay, and then when I evaluate it, I get pi. This becomes 6 plus 4 to the e to the negative 2 power minus e to the negative 4 over 2 minus, then parentheses, this gets a 0, but remember this becomes 4 e to the 0 minus e to the 0 over 2. Then pi becomes 6 plus 4 e to the second power minus 1 over 2 e to the fourth power minus 4 plus 1/2. So this becomes pi. 6 minus 4 is 2. 6 minus 4 is 2 plus 1/2 becomes 5/2. So this becomes 5/2. I feel like we did this one. I think this was exactly the one that we did in class. So that's going to be the volume. So do we see how we did this? So any questions about this particular problem? When there's a constant function, so again, you just have to understand the geometry of it. So in this case, our constant function, right, with respect to the axis of symmetry, that difference is always the same. So because that difference between the axis of revolution and the constant function is always constant, because it's a constant function with a constant function, then that radius will always be 1 in this case. Now, the question was brought up that what if this axis of revolution was not y equals 2? What if it's something else that's below the sketch? So why don't we look at that? Why don't we look at the same problem? So you start to see that you can create these problems on your own. You don't need a textbook. You can create them on your own. So I'm going to set the same equations, right? Y equals e to the negative x. Y equals, what is it, 1? And x equals, what was it? X equals 2, right? Now, instead of rotating it or revolving the sketch around y equals 2, why don't we say negative y equals 2? What's the difference about y equals negative 2? Now, again, the hardest part is setting up the integral. So if I were to do the same exact drawing, I'm going to have e to the negative x like this, right? This is y equals e to the negative x. And then I would have, again, the constant function y equals 1, right? So I got y equals 1, and then I got x equals 2. Sorry, I should write this with the... Okay, so I got x equals 2, right? And y equals 1. So then look what I have. I got the same sketch, same region. Now, the only difference is that I have a axis. My axis symmetry is what? Y equals negative 2. That's the axis. I'm sorry, why did I say axis symmetry? Axis of revolution. I always keep on saying that. Now you have to revolve it around this new axis. So then what's the new shape that's going to look like? I'm going to look like something like this. It's like a little volcano, except that the volcano is hollow, and I got what is this, the right shape? Yeah, it looks something like this. Do you guys see that? I don't know if something like this. Of course, my drawing is not what you would want to see. Do you guys see that? Again, the most important thing is setting up the integral. So I know that's going to be pi is going to be part of it. The washer method from 0 to 2 again, that hasn't changed. That hasn't changed. The bounds of integration still go up until 2 for x goes from 0 to 2. Now the problem is what's the outer and what's the inner? What's the outer radius and what's the inner radius? That's the most difficult part to figure out. Now, because my axis of revolution is completely different than the previous example, then I cannot use the same outer radius, obviously, because now it's a completely different shape. Now the question is, what is that outer radius? So remember how we do this? We choose a particular x value, correct? And we want to figure out what is the farthest function from my axis of symmetry, axis of revolution in this case. What's the farthest one away? Is it this portion here of the graph of the sketch, or is it this portion? What's farthest away? Obviously, it's going to be what?
Y equals 1.
Y equals 1. Okay, so once we've established that fact, then how large, and since it's constant, what's the constant radius for the outer function? It will always be what? What's that radius? Do you guys see it? What is this distance here? From y equals 1 to y equals -2. What is that distance always going to be? This is very simple mathematics. No, it's not 0. Guys, what is 1 minus -2 equal? It equals 3. That's right. The outer radius will always equal 3. Do you guys see that? And then what's going to be the inner radius? Well, now I have to look at the closer function, don't I? And the closer function is given by what? E to the -x. So then what's going to be the distance from the axis of revolution to e to the -x? What is this distance here? E to -x minus 2? No, no. It's going to be e to the -x minus -2. Do you guys see the difference? Because really, remember radius, the radii is a distance. It's always going to be a positive number. It can't be a negative distance. So the radius is always positive, irrespective of where I am in the graph. Even if I'm in with negative values, my radius will always be a positive. So then, even though these are negative values here, the distance is exactly what? Not -2. The distance is 2 from the axis, right? From the x-axis. And then you add on what? You add on a bit more. You add on a little bit more on the y value, which is e to the -x. So that's why I get e to the -x plus 2. If you understand this, then you understand any of these kind of problems. And now the setup, it becomes what? It becomes 3 squared minus e to the -x plus 2 squared dx. That's going to be my parabola. I mean my integrand. That's going to be the setup. So then if you guys want to continue, this becomes pi from 0 to 2 of 9 minus, this is parentheses. What does this become? This becomes 4 plus 4 e to the -x plus e to the -2x dx. This becomes pi from 0 to 2 of 9 minus 4 e to the -x minus e to the -2x dx. So this becomes pi evaluated from 0 to 2 of 5 minus 4 e to the -4x minus e to the -2x dx. Antiderivative 5x minus, sorry, should not be -4, it should be -x. This is going to be positive 4e to the x, and this becomes positive e to the -2x, sorry, it should still be negative, over 2. And I'm going to evaluate this from 0 to 2, pi. And then I'm going to evaluate it at 2, and I get 10 plus 4 e to the -2 plus e to the -4 over 2 minus 5 times 0 plus 4 e to the 0 plus e to the 0 over 2. So this becomes pi, this becomes 10 plus 4 over e squared plus 1 over 2 to the e to the fourth minus 4 minus 1/2. 10 minus 4 is 6 minus a half is 5.5, which should be what? So this is going to be equal pi times 5.5 plus 4e squared plus 1 over 2e to the fourth. And then this becomes what? 10 over 11 over 2. So it becomes 11 over 2 plus 4e squared plus 1 over 2e to the fourth pi. So do you see how we just kind of made a question up? A lot of these questions are just made up. So Samantha, does that answer your question? Do you see the difference in how having an axis of revolution below the x-axis changes? It doesn't really change much, right? So Tassif, yes, I can do the next one, 1.6 number 5, but let me finish Edwin's. What was it, Edwin? No, it was Rocky. Rocky said 2 and 3. So I'm gonna do 3 next on the same section, and then I'll do yours. So 3, okay. So everyone's okay with this? Just before moving on. If everyone's okay. All right. So let's look at the next one. Number 3. So number 3, we got x minus y equals 1. Y equals x squared minus 4x plus 3. And I want to revolve the region about y equals 3. Okay. So looks like since we're revolving it around a horizontal axis, what I would do is I would write everything in terms of y. So this is a linear function, and we can clearly see that y is equal to x minus 1. Okay? And then we have y equals x squared minus 4x plus 3. So the first thing we have to do is figure out what are the intersection points. Figure out the sketch. So I got something like this. X minus 1, something like this. So this is x minus 1. Let me make this a little better. Okay, so this is 1, this is 1. Now, what is x squared minus 4x plus 3? I can factor this, right? X minus 3, and this is x minus 1. So I know that I'm going to have at 1 and at 3. I'm going to have something that looks like this. So it looks like I may need a better graph of this. So I'm going to cross the x-axis here, and I'm going to cross it here. So my region will look something like this. Now, I know for a fact that this will be one of the points of intersection, right? So this is one of the points. This is 1, 0. And I need another point. So I have to figure out what that point is. And I can do so by setting the equations equal to one another. So I know that x minus 1 equals x squared minus 4x plus 3. This becomes x squared minus 5x plus 4. Set it equal to 0. X minus 4, x minus 1 equals 0. So x equals 4 and x equals 1. Well, we already figured out that x equals 1 is one of them. The other one will be x equals 4. So this is going to be my x values here. So this will be 4, comma. And if I plug in 4, I would get 4, 3. So that's going to be my points, right? So I know for a fact that my volume is going to include pi from the x values from 1 to 4, right? That's going to be my bounds of integration. And now I'm going to be revolving this about y equals 3. So y equals 3 is where? This is y equals 3, axis of revolution, right? And so when I revolve this, I'm not going to be able to fit everything in here. So maybe I'm going to move this to the bottom here. So if I were to revolve this, it would be kind of strange shape. Something like this. Something like this. I don't know if yeah, I think something like this. Right? It's very hard to draw this. But the idea is that this sketch here, this region here, becomes three-dimensional shape. And now the hardest question of this is what's the outer radius and what's the inner radius? That's it. That's the hardest part. If I can figure that out, I'm done. Well, in a sense. So remember, the outer radius is the function that is farthest away from the axis of revolution. What's my axis of revolution? Y equals 3. What's the farthest function? Is it this one or this one? Obviously, it's the one beneath it. Now, what is that distance? That's the hard part. What is this distance here? How do I express that distance? Well, think about it. I have a constant function, 3. And then what's the difference between 3 and the lower function, x squared minus 4x plus 3? So that difference is going to be the distance. The distance is always a difference between the functions. So my outer function will be what? 3 minus parentheses x squared minus 4x plus 3. Do you guys see that? Do you guys see why that is? That's right, Samantha. But make sure you put the parentheses around the x squared minus 4x plus 3 because you're subtracting a polynomial from each other. And when I do that, I have to distribute the negative sign, right? I have to distribute that negative sign. And if I do so, I get the 3 minus 3 that cancels out. So really what I get is this. I get 4x minus x squared. That's going to be the outer radius expression. And what's going to be the inner radius? What's going to be this guy here? The difference between this and this. But what is this? This is x minus 1. What is this? 3. So 3 minus x minus 1. So make sure you put that parentheses. 3 minus x minus 1. Distribute the negative, and I get 3 minus x plus 1. And I get what? 4 minus x. My inner radius. So my outer radius is what? 4x minus x squared minus 4 minus x squared dx. Do you guys see that? This is the hardest part of this problem. And then after this, shouldn't it be kind of like smooth sailing? Well, hopefully. Because then I can do from 1 to 4, I can expand this and I get what? So more algebra. This is all a lot of algebra. So I multiply 4x minus x squared. And so we make sure everything is okay. 16x squared minus, this becomes what? 8x cubed plus x to the 4th. So this is 16x squared minus 8x cubed plus x to the 4th. And then I got 4 minus x squared, which becomes 16 minus 8x plus x squared. And make sure you put the parentheses around that. This is 16 minus 8x plus x squared dx. Pi from 1 to 4. This is 16x squared minus 8x cubed plus x to the 4th minus 16 plus 8x minus x squared dx. This becomes pi from 1 to 4 of 16x squared. Can I combine anything? Yeah, the only thing I can combine is the x to the 5th. So the 15x squared. So this becomes 15x squared minus 8x cubed plus x to the fourth minus 16 plus 8x dx. If you want, we can rearrange this from increasing as a standard polynomial standard form. So this would be x to the fourth minus 8x cubed plus 15x squared plus 8x minus 16 dx. Then taking the antiderivative of this should be straightforward. X to the fifth over 5 minus 8x to the fourth over 4 plus 15x cubed over 3 plus 8x squared over 2 minus 16x evaluated from 1 to 4 pi. Then this becomes what? 4 to the fifth power over 5 minus 8 times 5 times 4 to the fourth divided by 4 plus this is just a 5. Yeah, this should just be a 2. 2, this becomes 5 times 4 cubed plus 4 x to the 4 to the fourth, 4 to the second power minus 16 times 4. There's a lot of computation here. Minus 1/5 minus 2 plus 5 plus 4 minus 16. My goodness gracious. Everyone follow me so far? I know it's a lot. It's a lot of computation here. And so from here, 4 to the fifth power, forget what 4 to the fifth power is. Pardon me, hold on.
1024.
Thank you. 1024, that's right. It should be, because that's like 2 to the 10th. And then this becomes double 4 to the fourth, which is 4 squared is 16. This is 256 times 2. 256 times 2 is 512, right?
Yeah.
Plus, and then 4 cubed, 64 times 5 is
320.
3 what?
320.
320. And then this is 64 again. And then this is 64 again. Great. And then this is minus 1/5 plus 2. I just have a whole bunch of stuff here. So I can just coalesce this all into one little thing. So 2 minus, so this is 9. This is minus 7. No, pardon me, plus 7. 7 minus 16, so it should be minus 9. So this whole thing is minus 9. This whole thing here is negative 9. If you subtract that, you get positive 9. And then you can just put everything into one single thing. 1024 minus 512 plus 320 plus 64. Well, 64 is canceled. And then I got minus 1 divided by 5 plus 9. And that's 4,000. So this is 42 4/5 pi. Let me just see. And then there might be something that's off, I think. Evaluated at 1. Do you guys get the same thing? You did? I think there's something off though, according to something off, something slightly off. Plus 4x minus x squared, then you got negative 4 minus x, and then you square that. and you get minus, minus, plus, and then you get 16 squared, and you get that, that's minus 16 plus minus 15 x4 minus 16 plus 8x. And this is 1 through 4. Yep, 1 through 4. And to the fifth power, fourth power, third power, second power, 16x. 4 to the fifth times 2x times 5, 4, and then 4x, and then 16 times 4, and then minus 1/5 minus 2 plus 5 plus 4 minus 16. Then 9 minus 2 is 7 minus 16 is negative 9. And then you added 9. Yeah, this should be, if we're going to do something here. So it seems to be a discrepancy. 4 to the 5th. It's one of those things, again, with the computation. But like I said, the most important thing, guys, is setting it up. Do you guys see how we set it up? If you guys see how we can set it up, then we're in good shape. Divide 1024 by 5. Did I not do that? Yes, thank you, Samantha. You came clutch. Clutch. Spotted it. That's right. So then now this should be a lot smaller. That was a little too big. So again, you can put this in your calculator. I'm just gonna tag that right along. That should be right. Now we're talking. So that that division, right? That's what got me. I didn't divide by 5 when I should have. I just went straight forward. I just focused on 4 to the 5th and not divide by 5. So once we do that, then we got the answer. Again, that's like a very minor detail, right? The most important thing is setting it up. So if you can get here, you've done 75% of the job. Everything else here is be extremely careful with how you expand it, be very extremely careful anti-differentiating it, plugging in the correct numbers, and then you have this whole a lot of bookkeeping here. That's not even like necessarily math anymore. It's just computation. Um, but good. Thank you, Samantha. Very good. Very good. Good eyes. So any other questions about this? So are we good? Again, the setup is the most important thing. The setup. If you got the setup, most of it should be straightforward after. Okay, so we've done 2 and 3, and now Tassif, we're gonna look at yours. Your question, you said 1.6. 1.6, number 5, right? Yeah, 1.6, number 5. So 1.6, number 5. So now we have, again, another washer method, but this time we have it around a different axis. So this is 1.5. No, sorry, 1.6. 1.6, number 5. So we got y equals x squared, y equals 0, x equals 4, about x equals -1. Okay. Again, like I said, setting it up is the most important thing. So y equals x squared, we should know what this looks like, right? This is y equals x squared. Y equals 0. Well, y equals 0 is the x-axis. And then I got x equals 4. a straight line, vertical. And what is it that I want? This region, correct? But I'm going to take the region. So you know what? I'm going to erase everything that I don't need. I don't need this. I just need a region. I'm going to take this region, and then what am I going to do? I'm going to revolve it around. So I may have to. I'm going to revolve this. This is the equation x equals -1. So this is my axis now. This is my axis. And this is what I'm rotating. I'm revolving around, right? So I'm going to have something that looks like this. Do you guys see that? It's like a bowl, but it has a hole in it. Now again, the what we're doing is we're doing a washer method, right? And if I revolve around the vertical axis, then the washer method would mean that I am finding the washers that are sliced horizontally but stacked vertically. So then I'm going to be looking at it from the y perspective. So then what are the y values that I care about? Well, y equals 0 is one of them, right? And then what's this point here? When x equals 4, what's this point here? What's the y value? This would be 4 comma what? No. If x equals 4, oh yeah, y equals, no, if x equals 4, if x equals 4, what does y equal? Not 2. It's actually 16, isn't it? Yeah, it's 16. So this is 16. Okay, so then the y values is what I'm going to differentiate upon. It's going to be the y value. So it's going to be all the way from 0 to 16. So this is 16. Again, the setup is the most difficult part. So the volume is going to be pi from what? From 0 to 16. Now what's going to be the radius? So I'm looking at it from this perspective all the way to the outer function here. What's the radius? What's this distance every single time? This is a constant, right? What's going to be this distance? Do you guys see? I think I made this way too big. X equals -1 should not be this far out. It should be a little closer. Sorry about that. It should be a little closer. But I just maximized it a bit. So what's going to be the distance here? If this distance here is 4, because x equals 4, right? This is x equals 4, and this is x equals -1. What's going to be the total distance between this line and this line? Anyone? What's going to be the outer radius? And that's perfect. The outer radius is 5. It has to be, right? It's always going to be 5 away. If you're 4 units away, remember we're only looking at it from the y perspective, right? But then we're looking at the distances in the x perspective. So what's going to be the distance here? 4 plus an additional 1, it's 5. So I'm going to have a 5 squared. And then what's going to be the inner radius? The inner one is going to be the axis of symmetry to the closer piece. So in this case, my function here is what? Y, this is y equals x squared, correct? But remember, when we're converting this into the y perspective, right? My washers are horizontally stacked or vertically stacked. So then that means that I have to rewrite this as x in terms of y. So to y equals square root of x. So then if this here is 1, and this additional piece here is what? Square root of y, then what's going to be my radius? My inner radius would be what? this is 1 here. Remember, it's the distance. So if this piece here is 1, and this piece here is square root of y, then the total would be, exactly, it's going to be 1 plus square root of y. And that's it. So I got this as minus 1 plus square root of y squared dy. That's my setup. Hardest part. We did it. Now it's just going to be computation from here on out. So this is from 0 to 16 of what? Of 25 minus, this is 1 plus 2 rad y plus y dy. This is pi from 0 to 16 of 25 minus 1 minus 2 rad y minus y dy. 24 minus 2 rad, I'm going to rewrite this as y to the 1/2 power minus y from 0 to 16 pi dy. This becomes 24y minus 2y to the 3/2. And then we're going to put this over 3/2, which becomes 4/3 minus y squared over 2, evaluated at 16 and 0. So far, so good. So does everybody follow this? I'm assuming that's a good. So then this becomes pi times 24 times 16 minus 4 times 16 to the 3/2 over 3 minus 16 squared over 2. And then 24 times 16 is 384 minus 4, 16, square root of 16 is 4 times 3 is 64 over 3 minus 256 over 2. So then 4 times 64, 256. So this should be 384 minus 256 over 3 minus 256 over 2. So let's see what we get when we do all of that. 384 minus 256 divided by 3 minus 256 divided by 2, which should be 128, right? So then my final answer becomes 512 over 3 pi. Any questions about this? Tassif, is this good? Do you see how we do the washer method for this? Yeah, the setup is the most difficult, is the most crucial, is the essential part of this problem. Once you have that and you completely understand why it is what it is, then the rest is just computation, anti-differentiation, and be careful with the numbers and the fractions and the symbols. This is the this is the place where you can get 1 point off, half points off, right? Because of the computation. But really, this is the crux of the problem here. It's this, setting it up. Can you do 1.5 number 5? 1.5. Yeah. Yeah, of course. 1.5 number 5. So 1.5 number 5. So I got y equals 1 plus secant of x. And I got y equals 3. And I'm going to rotate this about the line y equals 1. Okay. So this is a goodie. The thing is that I'm not sure if you guys have seen what the equation of cosine x is. secant x. Remember, secant, so recall, y equals secant of x is really y equals 1 over cosine of x, correct? Now try to remember what cosine of x looks like. Cosine of x looks like this. It looks like this, right? Let me make this a little better. That's what it looks like, right? Now, what's 1 over cosine of x look like? I don't know if you guys seen it before, but it looks like something like this. It has every time cosine is 0, secant of x is undefined. So we have asymptotes whenever cosine equals 0. And then 1 divided by 1 here is 1. But then 1 divided by smaller numbers, think about cosine gets smaller and smaller, right? But 1 over smaller numbers become bigger and bigger. So this is actually graphs of secant. This is a graph of secant. And then also secant again appears here. So secant is a little bit strange, but it's related to cosine. But so then this is 1, correct? This here is 1 here. But now take the graph of secant, which are these little graphs here. These are graphs, right? And I'm going to add it by 1. So I'm shifting it up by 1. So in reality, what I'm really going to get, so let me just draw that in a separate graph. In reality, I'm going to have this. This is 1. This is 2, right? This is a piece of 1 plus secant of x. And then I'm going to evaluate that across. Then I have 3 here. 3 is coming across. And this becomes my region because I'm bounded between secant, right? I'm bounded between 1 plus secant of x and y equals 3. And now what am I going to revolve it about? Y equals 1. So I'm going to take this region here. I'm going to take this region here. And I'm going to revolve it around the line y equals 1. I don't know why my lines are like so skewed. So I'm going to get something that looks like this. Right? Something like looks like this. This portion here inside is hollowed out, and we have something around that's physical, that's solid. But again, the setup, and another thing we have to figure out are the points. We have to figure out where are the points of intersection. Where are the x values that my function is going to? What are the bounds? So this is pi, and what are the bounds? So then I have to set it equal to one another, right? I have to set 1 plus secant of x. I have to set it equal to 3. Then I subtract by 1, and I get that secant of x equals 2. What does that mean? That means that 1 over cosine of x equals 2. What does that mean? That means that cosine of x is a half. What does that mean? That means that x is equal to what? What values of x makes cosine 1/2? And remember, we keep it in radians. Yeah. What is cosine of what angle gives me a half? So cosine of pi over 3. That's right, 60 degrees. So this is pi over 3. So this portion here is going to be pi over 3. And this is going to be negative pi over 3. Same thing. So then my interval is going to be from negative pi over 3 to pi over 3 of what? What's my outer radius? Hard part. What's the outer radius? And what's the inner radius? Well, the outer radius, remember, depends upon the axis of revolution. and the farthest function away. But then it's a constant function, isn't it? It's 3. It's always 3. And the axis and the distance between y equals 3 and y equals 1 is always going to be what? The distance is always what? The outer radius will always be
2. I mean, yeah.
2, obviously. And then what's going to be the inner radius? What's going to be this distance here, right? Whatever this guy is, we're going to subtract it with 1. Because I want to figure out this. Do you guys see how we do that? Do you guys see that this here, 1 plus secant, is this distance here? That's what the y equals 1 plus secant x is. The y value is 1 plus secant of x. And what is that y value? It's the distance between the point and the x-axis. But of course, I don't want that distance. I want to take away that 1 that's in between. That's why the difference here is 1 plus secant of x minus 1. So if I do 1 plus secant of x minus 1, then what do I get? I only get secant of x. So then what do I get? I get that this is 1 minus, pardon me, 2 squared minus secant of x squared dx. And this becomes what? 4 minus secant squared x, evaluated at negative pi over 3, pi over 3, pi. Do you guys see the setup? If you got the setup, you got everything. Now, once we got the setup, what's the antiderivative? What's the antiderivative?
Would it be 4x minus tan x?
4x minus tan. That's right. Evaluated from pi over 3 to negative pi over 3.
Wait, Professor, I got a question. Could this be considered an even function?
Correct.
Oh, okay.
Yeah, this is even function. So actually, I would prefer, right? Wouldn't we prefer not to do all of this and rewrite this as 2 pi instead from 0 to pi over 3? It's a good catch. 4 minus secant squared x. So this is even, guys. This is an even function. And you can clearly see that. You can clearly see that by the setup here. Or just by plugging in negative x, you see that it's always going to be positive, so nothing happens there. Doesn't change it. So now I can say v 2 pi. This is 4x minus tan x from 0 to pi over 3. This equals 2 pi times 4 times pi over 3 minus tan of pi over 3. This is 2 pi, 4 pi over 3 minus, what's tan of pi over 3?
Radical 3.
Radical 3. I'm done. Any questions about it? About this? The setup? Remember, it's the setup. The outer radius, inner radius, the larger radius, the smaller radius. If you can see that and find that expression, then plugging it in, anti-differentiating it, no problem. So what do we say? Good?
Looks good.
So we haven't touched arc length at all today. That's another, I guess, another thing we can do. If you guys like, we can do this tomorrow as well. Maybe a little earlier. Not that late. So maybe like 7 to 8 if you guys are interested. I would also have another session just like this.